This is the video for lesson 2.4, part B. We are still working on factoring and solving polynomials. And so after this lesson, you're going to be able to completely factor polynomials in quadratic form and factor them by grouping. So that's a new task that we're going to be learning today. So just to take a look at what we've already done, remember that if there is a greatest common factor, that's what we want to check for first. We're going to be able to factor each binomial or trinomial completely. And so we don't want to stop factoring until there is nothing left to factor. So that's one of the things I want to write down is continue factoring until there is nothing left to factor. All right, so keep going. So if we take a look at this first polynomial, it looks to me like I have a 3 common in each of these coefficients, and I also have an x squared common in each of the terms as well. So my greatest common factor is going to be 3x squared, and that means that that goes out in front, and now I'm going to find out what's left. So 3x squared, when it goes into 3x to the fourth, all that's left is x squared, and the next term is going to just be 3x, and then of course negative 70 because 3 goes into 210 70 times. Now I'm not done though, because this polynomial still has possibility of factoring. What two numbers multiply to negative 70 but add to negative 3? And I came up with negative 10 and positive 7 because those multiply to negative 70 but sum to negative 3. So I will have an 3x squared times x minus 10 times x plus 7. And that is my final factoring of this polynomial. So again, always check to see, is this completely factored? You know, the first step may not be your last step. All right, so let's take a look at problem C. I'm going to have you guys do problems B and D on your own. So you can watch this next problem and then try those other two problems on your own. So the first thing that I look at is like, well, these look like they could be the difference of squares, right? Because it's subtracted, I see a couple things that are perfect squares. However, let's take a look and see if we have a greatest common factor before we start looking for a difference of two squares. And the number 25 goes into 100 and it goes into itself. So I'm going to pull out the 25 as part of the greatest common factor, and c squared is also a common factor. So my greatest common factor is 25c squared. So look carefully before you start trying to take the square root of things if that's your initial choice. You know, if you think that's what you're first going to do, try to see if there's something else you can do first just to make sure. So how many times does 25 go into 100? It goes in 4 times, and there is a c squared left there. And then I have just minus 1. Now, I'm not done. This here can still be factored. It is the difference of two squares, isn't it? Because 4 is a perfect square, 1 is a perfect square, so I'm going to take out 25c squared, and then my 4c squared minus 1 is going to end up being 2c plus 1 and 2c minus 1, because when we take this, when we factor a difference of two squares, really we're just making sure that we have the same thing in both binomials, but the sign is different. Okay, so here's my final factorization of this polynomial. All right, so this information that we just went over is just recall from our previous lesson. And now we're going to get into our next new task. So factoring other quadratic forms that are trinomials. So recall that a quadratic trinomial can always be written in this form, ax squared plus bx plus c. And as you might remember, to factor this type of trinomial, when a is equal to 1, right, this coefficient out here is 1, you find two factors of c that also sum to b. Okay, but what is the multiplicative relationship between the highest exponent, in that case, and the second exponent, which is just 1? Well, it's the first exponent is double the second exponent. So the exponent here, or the degree of the polynomial, is 2, but the exponent here is 1, and we know that 2 is 2 times 1. So the first exponent, go ahead and write this down, is 2 times, or we could call that double, the second exponent. Now that's kind of obvious here, but I want to bring up another kind of problem here, another type of polynomial with different exponents. We're really used to this form, ax squared plus bx plus c, but what about a problem that looks more like this, where we have x to the fourth plus 2x squared minus 8? Is it true that the first exponent is twice or double as big as the second exponent? Yes. Okay, so we're going to learn how to deal with this type of problem. So let me give you another example. How about w to the sixth plus 8w to the third minus 9? Okay, is it true that the first exponent is twice as big as the second exponent? Yes, it is. So the trinomial, this type, and all of the examples that I just gave you here and here, we say are in quadratic form due to the fact that the first exponent is double the second exponent. Okay, and since they're all written in the same form, they can all be factored the same way. But you do have to be careful when you're writing your answers to accommodate for the higher exponents. So we're going to do some example problems on the back side of this page. Okay, so example 2 says to factor each quadratic form trinomial completely. And of course, before we start, we want to look for a greatest common factor. So in this case, we have a 6 as the exponent, a 4 as an exponent, and a 2 as an exponent. What is the greatest common factor of these three terms? Well, I think 4 can go into 4, 4 can go into 20, and 4 can go into 24. So I already know that 4 is going to be part of my greatest common factor. And then since t squared is right here, I can use t squared. That goes into t to the fourth as well as t to the sixth. So my greatest common factor is going to be 4t squared. And what is left? Well, it looks like t to the fourth would be left for that first term, and 5t squared, and then plus 6. So the way that you can check to see if your work is correct, of course, is just multiply the outside greatest common factor times everything, and you'll find out if you get back to this, then you know that your answer is correct. All right, well, we're not done factoring here, and if you notice already, t to the fourth is, the exponent there is twice as large as t to the second. So we are going to do a factoring like we were just describing on the front of this page. So we can factor this into two binomials, and the first binomial is going to be t squared, because that's the square root of t to the fourth. Not because it's the square root, but because half of 4 is 2. So that's what I'm going to put in my binomial there. Now, what two numbers multiply to 6 but sum to -5? You might think they are 6 and 1, or 6 and -1, or -6 and +1, but that doesn't work. So we're going to have to go with two negative numbers. The two negative numbers that we're going to use are -3 and -2, because they do multiply to +6, but they sum to -5. So now we have our polynomial completely factored, and I just wanted you to remember that because this number 4, this exponent here, is twice as big as the second exponent, we still had some more factoring to do. So I would like you to try this problem over here, problem B, on your own. So you're first going to look for the greatest common factor, and then you should be left with some numbers in the exponents that are larger than what you've been working with before. So use this example here to go back to if you need to. All right, let's take a look at our final new idea of the video, factoring by grouping. So what happens if not all terms of the polynomial have something in common? So previously we were looking for greatest common factor, but what if we don't have any greatest common factors? So these are going to be places and times that you're going to use factoring by grouping, and we're going to go through that right now. So usually there will be 4 terms, okay, and what we're going to do is we're going to divide the 4 terms into 2 separate ideas, or 2 separate things to factor. Okay, so what we're going to have is we're going to take the common thing out, and we're going to leave the non-common things inside. Okay, same thing here. So we're going to take the thing that the two terms has in common, and put that in front of the binomial and leave the other parts inside. So let's go ahead and try a couple of these, and then I'm going to have you try one on your own as well. So let's take a look at if we divide this down the middle. Okay, so we don't see any common factors. We don't have a greatest common factor between all four terms. So I'm just going to use and go through this separately. So I'm going to look at x cubed minus 3x squared. What is the greatest common factor of this? And then I'm going to do the same thing on the right. What is the greatest common factor of this? And then I'm going to factor just like I would. Okay, so what is common? Well, x squared is in both of these. So I'm going to take an x squared out, and then I'm going to leave an x inside for my first term, and a negative 3. Now, here's the key. If you notice up here, I have a plus b and a plus b. These must be the same. Okay, so the information that goes inside the two binomials has to be the same information. So we already know on the right-hand side that x minus 3 is going to be what we leave inside of there. So what is going, because this one was, what is going to be the greatest common factor on the left-hand side? Well, it looks like it's going to be negative 16, because negative 16 is common in 48, and it's common in the negative 16x. So now what I have to do is I have to take the things that are the greatest common factor from each of these and put those in a binomial. Okay, so now x squared minus 16 is in a binomial, and then the x minus 3 is going to go into a binomial as well. So, and you might think you are finished with your factoring. However, let's take a look at this binomial. This looks like it is a difference of squares. So we need to take the square root of both of these. Remember, you never stop factoring until every single term is factored completely, or every single binomial is factored completely. So that's going to end up being x plus 4 and x minus 4, and then we have our x minus 3 still as our final answer. So here is the actual finished factoring of the original polynomial that we started with. So this video will be posted on YouTube, so you need to make sure that you have this information clear in your mind, and if not, replay this video a couple times, or this portion of the video. I am going to do another problem right now before I ask you to do problem B on your own. So this one over here, problem B, is going to be the one that you try on your own. So let's just review. When you see a polynomial that does not have any common factors, with all of the terms, split it up. Let's just factor these two terms, and then we're going to factor these two terms separately. Okay, what's the greatest common factor in these first two terms? It looks like it's just x squared. Okay, what's left? And x is left, and plus 1, because x squared times 1 is x squared. All right, how about we then factor this? Well, there's nothing really in common there because it's an x and a 1, so we can't say there's anything in common. However, we do know that x plus 1 has to be what we put in the second binomial. Remember what we said, that the binomial information has to be the exact same. So a plus b and a plus b has to be the same in both of those, on the left and on the right. So if I look at the information here, x plus 1, well, what is the greatest common factor? I'm just going to go ahead and put a 1. Okay? 1 times x is x. 1 times 1 is 1. The reason I need something here is because, remember, these two things that are the greatest common factor go into their own binomial. So I have to have an x squared plus 1. Notice that the sign in front of the 1 is a positive there. And then I'm going to take the binomial that I had x plus 1 in, and that's going to be part of my answer. And upon first looking at this part, it almost looks like we can factor some more, but remember, it's the difference of squares that we can factor, and this is not a difference, it's a sum. So this is going to be our final answer for this problem. We started off with x cubed plus x squared plus x plus 1, and we factored it down to this. Now this may take some practice, so be patient with yourself. If you need to watch this portion of the video again, please do that, but I would like you to try Problem B over here, so you're going to be looking for a greatest common factor amongst these two terms, and then a greatest common factor amongst these two terms. And remember, whatever you put in the parentheses here is going to have to be the exact same. So whatever's in the parentheses on the left also has to go in the parentheses on the right. All right, I will be taking some questions in class, so please try your best on these on your own problems.